How are you, my friends? This is Calculus 1 solved questions. In this video, we will use implicit differentiation to find some derivatives. This is part 1, so you can expect, guys, part 2 and maybe more on implicit differentiation. Question number 1, given the equation 2y is equal x squared plus sine of y, we need dy over dx. Y is a function of x. And it's not easy here to find y in terms of x. So that's why we need to use implicit differentiation to find dy over dx. So the equation here is 2y equals x squared plus sine of y. So this cannot be solved for y. So step number 1, take the derivative of both sides by implicit differentiation. So the derivative of 2y will be the derivative of 2y, the derivative of x squared, the derivative of sine of y. So this will be 2 times dy over dx. The derivative of x squared is easy, just 2x. And this is sine of y. Remember, y is a function of x. So the derivative of sine y will be cosine of y times the derivative dy over dx. Now rearrange this last equation here to solve for dy over dx. So I leave this one here. I bring this cosine of y times that on the other side with negative. Leave the 2x there. Take a common factor here, dy over dx. In the bracket, I have 2 minus cosine of y equals 2x. Let's divide by 2 minus cosine of y. So the derivative dy over dx, this is what we need, will be 2x divided by 2 minus cosine of the y. We cannot cancel here the 2 because we have a subtraction. Be careful. Now in question number 2, we need to use implicit differentiation also on the equation square root of x plus square root of y equals to 1 to find the derivative dy over dx or y prime. So this is the solution here. Let's take the derivative on both sides. D of square root of x over dx, d square root of y over dx, d of 1 over dx. The first one is easy, x to the power half, find the derivative. It will be half x to the power minus half. This one, remember, y is a function of x. So that's a chain rule here. Half y to the power minus half times dy over dx. Because y is a function of x, and the derivative of 1 is 0. So what can we do? Take this one on the other side, because we have dy over dx with a minus, and then multiply by square root of y. So we get dy over dx is minus square root of y over square root of x, or we can write it as minus 1 square root y over x, or you can rationalize the denominator if you like. Now, question number 3, use implicit differentiation also on the equation 2 times e to the power minus x plus e to the power y equals 3e to the power x minus y to find the derivative dy over dx. So we do the same, use implicit differentiation, take the derivative on the left is equal to the derivative on the right, then use the chain rule. So the derivative of this first term will be 2 times the derivative of the u here on the minus x, it's minus 1, times the same function, e to the minus x. The derivative of e to the power y will be also e to the power y times the derivative dy over dx, because y is a function of x. This one, 3, is a constant. E to the power x minus y, we leave it as one function, times the derivative of the power here. This is like q. Now the derivative of the x is 1, and the derivative of the y is only y prime, or dy over dx. Now when you have to do some work, I left it for you, very simple. Multiply this times 1, multiply this times dy over dx. Take dy over dx with all the terms on one side and the other terms on the other side. Then divide by the coefficient of dy over dx. You will get, try it yourself please, 1 or 2 steps. the dy over dx will be 3e to the power x minus y plus 2 e to the power minus x, all divided by e to the power y plus 3 e to the power x minus y. Question number 4 is interesting. Find the slope of the tangent line to the graph of the equation y to the power 4 plus 3y minus 4x cubed is equal 5x plus 1 at the point 1 minus 2. So what do we have to do? The whole idea is to find dy over dx, which is y prime, which represents the slope. So we can start by implicit differentiation on the right. On the left, the derivative of y to the power 4 will be 4y cubed times the derivative dy over dx plus 3, this is a constant, dy over dx. Now this is only x, remember, 4x cubed, so it will be minus, from the question, 12x squared. The derivative of 5x will be 5, the derivative of the 1 will be 0. Now take here a common factor dy over dx and move minus 12x squared on the other side. So it becomes 12x squared plus 5 on the other side. Here with the common factor we have 4y squared plus 3. Divide by this coefficient, so dy over dx will be 12x squared plus 5 divided by 4y cubed plus 3. Now we have the point 1 and minus 2. We need the slope. Just replace here the value of the x by 1 in the derivative, and the value of y minus 2, it is given here. I can show it to you. It's given 1 minus 2. This is x and this is y. Okay, when you replace everything there, the slope will be minus 17 over 29. For more questions on implicit differentiation, you can see lecture number 13. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.